Hi guys, today we're going to take a look at question 6 of the 2017 exam paper 2. So we are going to take the Earth as a sphere with radius 6,371 kilometers. So Jack is standing on the cliffs of Moher at the point J, which is 214 meters above sea level. He is looking out to sea at a point H on the horizon. Taking A as the center of the Earth, find JH, the distance from Jack to the horizon. Give your answer correct to the nearest kilometer. Okay, so we have these distances AH, the radius of the Earth, 6,371 kilometers. And we know that J is 214 meters above sea level. So this distance here won't draw a straight line. Here is 214 meters, and we know that this distance is 6,371 kilometers. So the distance AJ is 6,371 kilometers plus 214 meters. So we can write it as, if we're going to keep it in terms of kilometers, 6,371.214 kilometers. Okay, and we want to find out what AH is. So we have this triangle AHJ, and we have the lengths of two of the sides. But that's not quite enough information to get what HJ is. But, and this is the key to the question, the line HJ, this line here, is a tangent to the Earth. It just about touches the Earth because it's the furthest point that a person standing at J can see. H is the furthest point. So JH just touches the Earth, so it's a tangent. So we can say that JH is a tangent to the Earth. And what do we know about tangents? Well, we know that tangents are perpendicular to the radius. Perpendicular to the radius. Which means that this angle here is a right angle. And so now we're just working with a right angle triangle where we'll be using Pythagoras' theorem, a squared plus b squared equals c squared. And so we get the length of AH squared plus the length of HJ, the two shorter sides, squared, equals the length of the longer side, the side opposite the right angle, the hypotenuse AJ squared. And we have these two values, AH and AJ, so we can just fill those in and solve for HJ. So 6,371 squared plus HJ squared equals 6,371 plus 0.214 squared. And so our hj is the square root. So if we brought this over and then took the square root, the square root of 6,371.214 squared minus 6,371.214. Sorry, 6,371 squared. And if we put that into a calculator, we get 52.22 kilometers. Or to the nearest kilometer, hj equals 52 kilometers. Very nice question once you realize that the line through H and J is a tangent to the Earth. Now on to part B. The cliffs of Moher at C are of latitude 53 degrees north of the equator, which we can see in the diagram. And on the diagram, S1 represents the circle that is at latitude 53 degrees. So this circle here. S2 represents the equator, the line around the middle. This here. And A is the center of the Earth. S1 and S2 are on parallel planes. Find the length of the circle S1 and answer correct to the nearest kilometer. Okay, so let's try and figure out what is it that we want to find out. So we want to find the length of S1, or in other words, the circumference of S1. And for that we have the formula C, the circumference, equals 2 pi r. So let's draw a diagram of the important things here. So we have this radius from the equator and then out to C, and then from C back into the center of S1. So this is directly here. Okay, well, we know that, so if this is the center of the Earth, A, this is our point C, and this length is 6,371 kilometers, the radius of the Earth. Okay, and so we are trying to find this length here, or let's just put it in purple. We want this to the center of S1, the distance to the center of S1. Okay, so we know that the circles S1 and S2 are on the same plane, so this is a right angle. These two lines are perpendicular. And since this is, so these are parallel, and this is 53 degrees, and so between two parallels, a line that goes through them makes the alternating angles equal. So this is also 53 degrees. So let's write that down. A line through two parallel lines. That's line through two parallel lines makes the alternate angles equal. One of our theorems makes the alternate angles equal. Okay, so we know that So we have this right angle triangle where we have one of the angles, and therefore, we technically have both of the angles. It would be very easy to get this one. It's just 90 minus 53, but I don't believe that we need it. But now we need a length. We know that the length AC, which is the distance from the center of the Earth to the cliffs of Moher at point C, is 6,371.214 kilometers. So we have this triangle here where this angle is 53 degrees. This length is 6,371. So this is A, C, and then the center of S1. Let's call this S. And we want to find this length from S to C. And then so this should be fairly easy since we have a length and an angle. So cosine of an angle in a right angle triangle is equal to the adjacent side over the hypotenuse, which in this case is the distance SC, or the radius, over the hypotenuse, which is 6,371.214. Sorry, this is a 0.214. And so we just get cosine of 53 equals radius over 6,371.214, and then just multiply by this denominator, and we get the radius equals 6,371.214 times cosine of 53, which is 3,834.29 kilometers. So that's the radius of this circle S1. So the length is just, so the length of S1 is just 2 pi times this radius, 3,834.29, which is 24,091.55 kilometers, or to the nearest kilometer, 24,092 kilometers. I would be interested to see, do the solutions use, did they take this length to be 6,371.214, or did they take it to be equal to the radius? Because it very much looks as if C is on the circle, which it technically shouldn't be, since in the last question they've told us that the cliffs of Moher are 214 meters above sea level. So I would be interested to see, do they take AC as 6371 or 6371.214? But either way, the answer is going to be so close. It probably, is only a difference of like it's probably only a difference of like 5 kilometers either way, which when you're talking about 24,000 kilometers, is a very small margin of error. But I think that this is probably, I think that this is the more correct way, since if they say that c is the cliffs of Moher, then it's not equal to the radius.